lots of things to do. So just a reminder of your final exam and your exam 3. I know there has been some confusion about the dates and all. So I included the dates in your course syllabus. So also I included that here, so there won't be any confusion. You have your exam 3 this Friday, and then we have the no week exam after that, and then on Tuesday, May 10th, we have the final exam. And I have been grading your extra credits and all that, and I finished that for my other class 275, and they were really happy with the results because they could see the increase in their grades. So I'm trying my best to finish grading today and tomorrow, so you'll see your increase, your grade increase as well, and be happy as well. So also, I posted your last homework assignment on Canvas, which is due this Wednesday. And also, I'm going to write your quiz today or tomorrow. And the reason that I put the deadline Friday is that next week is no week exam. So I didn't want you guys to have any quiz or something during the weekend. But if you prefer the deadline be on Sunday, not Friday, I'm happy to put the deadline on Sunday, so you have more time for your quiz. How many of you would like that? Okay, so most of you. So when I post the quiz, I put the deadline on Sunday, so you have more time for that. But I highly encourage you to do it beforehand, so you have some sample questions for your exam. And as I said, I included all the materials from last semester on Canvas. It's ready for you, so feel free to just look at them, and also the study guides, everything is there. Okay, any question about our exams, final exam, quiz, homework, anything? Good? Okay, if no question, I'm going to continue with the chapter 10, and hopefully I can finish as much as needed for your lab tomorrow, but probably I cannot teach you all the materials needed for your lab tomorrow, so your lab TAs should explain to you more, compared to what I'm teaching you today. But okay. So what we talked about during the last session was Lewis structures or dot structures, right? In general, representing valence electrons with dots. And as you remember, we said Lewis model or Lewis structures or dot structures are really simple, right? You just have the atomic symbol of an element and put the valence electrons around them. And what I asked you in the previous extra credit homework class activity, I said that in Lewis structure we put protons around the atomic symbol. That would be false, right? We put valence electrons. So if I tell you core electrons, that would be wrong, okay? So can anyone tell me what is number of valence electrons in nitrogen? 5, right? Because it is located in group 5A, right? So it has 5 valence electrons. So for your main group elements, you don't even have to write the electron configuration. What about boron? How many valence electrons it has? 3, right? Because it's in group 3A, so it has 3 valence electrons. What about carbon? 4. It's in group 4A, and remember it should have this A too, because if you just look at the group number, you might say that carbon is in group 14, right? But it doesn't have 14 valence electrons, it has 4. So it has 4 valence electrons. Okay, any question about this? Good? Okay, now if I ask you in exam, and I'm going to ask you, what is the dot structure or Lewis structure? All right, what is the Lewis structure for fluorine. And then I give you these. Like, I have 1 electron here. I have 8 electrons. I have 1, 2, 3, 4, 5, 6, 7. Or I have 3. Which one is Lewis structure for fluorine? C. Okay. Now, let me ask you this. If I ask you, what is the Lewis structure for F minus? So how does it, so what happens when fluorine gets 1 electron? Exactly. So previously, here you had like 7 electrons around it. Now, so this is fluorine itself, right? When it gets 1 electron, what happens is that, as your friend said, it reaches an octet. Because now there are 8 electrons around fluorine atom. So this would be structure of F minus. And we denote minus above it to mention, to emphasize that this is an anion. Good? Questions? So something that I kept or tend to ask in exams, I say, is the following statement true or false? False. Lithium loses 1 electron to reach an octet. Let's say true, false.
True.
How many say true? How many say false? So let me ask you this. What is atomic number of lithium? Atomic number of lithium is 3, right? And I give you the periodic table. It is in group 1A. It has 1 valence electron, right? It has 3 electrons overall. So if I want to write the electron configuration, what should I write? 1s2, right? What else? Exactly, 2s1. So when we know, all of you hopefully know that lithium loses 1 electron, that's why we had Li plus, right? Loses 1 electron. So when it loses this electron, how many electrons does it have in its outermost shell now? 2. Do you remember what we call 2? Duet, right? It's kind of like duet, or like when 2 people are involved and they're singing together, duet, right? So that's the same thing. Octet means that we have 8 electrons in outermost shell. Now we have 2 electrons. So that's why this sentence would be false. Remember I told you hydrogen, helium, lithium, beryllium, right? They were exceptions. That they wouldn't reach an octet, they would reach a duet. Good? Questions? Okay. If no question, let's now review ionic versus covalent bond. And I have these in your previous lecture and also slides, so you don't have to worry about that. Can anyone tell me quickly what was the difference between an ionic bond and a covalent bond? Yes?
An ionic bond is a metal and a non-metal.
Uh-huh.
Covalent is 2 nonmetals.
Exactly.
Sharing electrons.
Yes. So in covalent bond, we have 2 nonmetals, and it also can be a metalloid and nonmetal, but we don't have metal for sure. And electrons are being shared. Okay. In ionic bonds, we have a metal and nonmetal, and we know that NH4 plus ammonium cation was an exception. But in general, except that, we have metal and nonmetal, and metal loses electrons, or electron, and non-metal gains one or more electrons. So electrons are being transferred. Metal loses, non-metal gains, okay? But for covalent bond, which we had like molecular compounds, right, that they had like covalent bonds between them, electrons are being shared, it's not transferred, kind of like reviewing that. Now, I give you this in exam, and I also gave you similar question in your quiz today. I say extra credit, so don't worry about that. And as I said, when I finish grading, I'm going to delete the extra credits. So I know that some of you are worried that your grades are messed up on Canvas, but this is like the most efficient way for me to assign extra credits, and it would be the fastest. So I'm going to delete that. So I add the grades to your grades, okay? So don't worry about that. Extras are extra. Okay, write the Lewis structure of the compound KCl. Okay, so what you do in this case, first of all, distinguish what type of compound do you have. Can anyone tell me what type of compound KCl is? Ionic, right? Because you have metal and non-metal. So it would be ionic. Can anyone remember what was the constituent cations and anions for this compound? Potassium and chloride. And we said we added IDE, like base name of nonmetal plus IDE chloride, but name of metal stays the same. Okay? Unless we have a metal that forms multiple charges, like mercury 1, mercury 2, copper 1, copper 2. In that case, we write the charge with Roman numerals. But in the case of potassium, it's only one type of charge, so we don't write anything. Okay, so that's that. Now, let me write each individual element. So potassium, how many valence electrons it has? 1. It's in group 1A. It has 1 valence electron. And for dot structures or Lewis structures, we write the atomic symbol, right? And then we put the valence electrons around it. And as I told you, kind of use the thing that we did when we were dealing with Hund's rule, that we put the electron around the element singly first and then pair them up. It helps you with writing the structures that I'm going to talk about right now. And next, let's do chlorine. Chlorine itself, not the ion, not chloride. Chlorine, how many valence electrons it has? 7, right? It's in group 7A. So we write 1, 2, 3, 4, 5, 6, 7. Okay. Now, so these are like individual atoms. Now, if potassium loses 1 electron, K plus means it has lost 1 electron, right? What would that be? Just K that has lost its only valence electron, right? So, and I remember that this K loses the electron. Who gets that? Chlorine, right? So now your chlorine here, previously it was like, you had that, now it gains 1 electron. What happens to it? You add 1 electron to it, and then you denote negative charge here to show that chlorine has gained 1 electron, and we denote positive here to show that potassium has lost 1 electron. And this is how we denote that. So remember, for your non-metal, you denote the number of electrons, you write it, okay? But for the non-metal, when it loses that, we just don't write anything in brackets, okay? But you denote the positive charge. Does that make sense? Any questions? Good? Okay. If no question, let's now try to write it for MgO. Or I guess I can write the complete question that write the dot structure, and I can ask you dot structure or Lewis structure, both are the same, for MgO. Okay, so first of all, what type of compound this is? Ionic, right? Because we have metal, non-metal. What is the charge of magnesium? 2 plus, right? It's in group 2A, the charge is 2 plus. What is the charge of oxygen? O2 minus. What is the name of O2 minus? Exactly. So O2 minus is oxide, MgO is magnesium oxide. Can I write magnesium 2 oxide? No. Okay, when you have only one type of charge, you don't write 2 with Roman numerals in parentheses because it's only one, right? Okay, now just first do it individually. What is the valence, number of valence electrons for magnesium? 2. It's in group 2A, right? And then you can put it like this, or this, or this. However you put it doesn't matter. As long as you put 2 electrons on different sides, right? That would be good. What about oxygen? What is the number of valence electrons for oxygen? 6, right? So I put 1, 2, 3, 4, 5, 6. Again, it's, as I said, it's a good practice to fill them singly first and then pair them up, because when we talk about covalent bond and we want to share electrons, that helps you to write the structures. So now we want to turn that into MgO. I'm going to write this so I can make modifications here. So what happens here is that magnesium atom has lost 2 electrons. So what I do here, I get rid of these 2 electrons, right? And who get those electrons? Oxygen, right? So I pair this one and this one. I put these 2 electrons here. So now what would be my charge here? 2 minus. What would be my charge here? Sorry, 2 plus. So my structure would be Mg2 plus O 2 minus. Any questions? Are we comfortable writing these? Okay. Remember, for the anion, you put the number of electrons, right, around it and then put 2 minus above it. So we emphasize that it has gained 2 electrons, for instance, for oxide. Okay. Now, let's practice. So if previously I asked you to write a compound, for your exam 2, write the compound that forms between sodium and sulfur. Remember? So first of all, what type of compound this would be? Ionic, right? Because we have metal plus non-metal. So what is sodium? Na. What is sulfur? S, right? Do you remember what is the charge of one sodium cation? Sodium is in group 1A, right? So the valence is 1, so it loses 1 electron, you have Na plus, right? What about sulfur? What would be the charge of sulfur? 2 minus, exactly, right? Remember that it's in group 6A, it needs 2 electrons to reach as an octet. That's why it's like S2 minus. So again, what we do, we write these individually. So sodium, how many valence electrons it has? 1, exactly. What about sulfur? 6, group 6A, right? 1, 2, 3, 4, 5, 6. And as I said, you can just write it any other direction. You can put these 2 electrons here, these 2 here, or like any other combination, that's fine. So now, can anyone tell me what was the chemical formula of a compound forming between NaN, or like sodium and sulfide? Exactly. We said one way is to just switch these two and write Na2S. The other way is that to say sulfur or sulfide has two negative charge, we should have two positive charge for our compound to be neutral. You have already one positive charge, so you should have two sodium. That 2 multiplied by +1 becomes +2. Okay, so now when you want to write the Lewis structure for Na2S or sodium sulfide, I should have 2 sodium atoms, right? Because you have 2 sodium atoms, each of them gives 1 electron to sulfur, so you have S2 minus sulfide. Does that make sense? So for that matter, I'm going to write this with different color here. So if I have my Na here, right, and then you have your S here, and then I write another Na here. So each of these NAs, they lose their electrons and they give it to this sulfur atom here. That's why now you have sulfide S2 minus and then Na plus. Okay. And something that I noticed, and I always tell my students that I want them to succeed as long as they care, they do well and all that. But there are some students, I mean most of them not, they are not in the class at this moment and they're not watching the lecture. So I'm trying to help everyone to pass and potentially get A's and B's. But there are some students, as I said, most of them not being in the class, that they don't attend the class, they don't get extra credits. So people who are getting C's or like, they're getting B, they just increase their grades and then they get A's. Students who are failing, they just fail and I cannot change the fact, and it's kind of unfortunate. By the same token, when I was looking at your grades for like the previous homeworks, or like extra credits, and some of them, out of 20, and then some students just get 4, or like zeros. So that is really unfortunate because as long as you listen to this, I asked you really similar, maybe just exact same questions, and some students don't get the extra credits, so it's kind of like unfortunate. But you need to pay attention in order to get those points. Anyway, so we have Na plus, I'm kind of like writing the structure here, S2 minus Na plus. Okay. Any questions? Are we good with this? So as long as you write, you'll be able to write the chemical formula that forms within the compound. You know that in Lewis' structure, if I ask you for Na2S, you should have 2 sodium cations, right? If you have 1, you know that is wrong, okay? And except, lithium and beryllium and hydrogen, some few that we talked about that they don't reach an octet, the rest should reach an octet. They should have 8 electrons in their valence. Okay, so that was writing Lewis structures or dot structures for ionic compounds. Any questions? Okay. So now let's talk about covalent bonds. And here it gets trickier, so I need all of you to pay attention. Lewis structure. And here, as I said, electrons are shared, okay? And I, start asking questions if I see people talking because it's distracting to me, so definitely it's distracting to people who are sitting behind you when you talk. Okay? Okay, so now, can anyone tell me an example of a compound that it has covalent bonds between their atoms? Yes? CO2, exactly. Another example? H2O, exactly. And that is exactly the example that I want to talk about. So let's talk about H2O. So how do you think we should write the Lewis structure for H2O? We start with hydrogen and oxygen, write it, and then go with the flow, okay? So what is Lewis structure for hydrogen? How many valence electrons hydrogen has?
One.
It has only one electron, right? And that would be its valence electron. What about oxygen? 6, right? 1, 2, 3, 4, 5, 6. I just put it like this, but as I mentioned, you're welcome to put it however you want. Okay. Now, here's the tricky part a little, that you have 2 hydrogen atoms for every oxygen atom, okay? So if you want to write that, let me write my oxygen here, and that's where I told you it's a good practice to have your atoms, when you have one single electron that is not paired, we call them non-paired electrons, in front of the other element that you're writing. And momentarily you see why that is a good practice. So if I put hydrogen here, it has 1 electron here, right? But we have 2 hydrogen atoms, right? The other one is here. So this is the Lewis structure for hydrogen that I wrote 2 times, right? And then here is for oxygen. So any questions from individual ones? Good. And as I said, if you put it here, it's kind of like we want to connect the single electrons. So it's good practice to have your atom that has one electron or non-paired electrons in front of the other one. So here, what I'm going to teach you is that these 2 electrons, we connect them with the dash or a line, and we call that a covalent bond. And we do the same here. We call that covalent bond. What that means is that this oxygen now, and I'm going to write it with another color, hopefully you can all see good. This oxygen now has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and it reached an octet. And that's what we mean by sharing electrons. Now, this hydrogen and this oxygen, they are sharing these 2 electrons. So if I count the number of electrons for this hydrogen, I say 1, 2. Okay? So hydrogen reached a duet, and it's the electron configuration of the noble gas after it. Okay? And the same thing with this hydrogen, it reached a duet. It has now 2 electrons. 2 electrons. Okay? So if I ask you in this structure that is just like so messy right now, but if I write it like this, okay? If I say now in this structure, how many electrons oxygen has? You count, there are 2 here, 4, 6, 8. So as I said, each dash or line represents 2 electrons. So it will be 2 single electrons, but it can also be 1 pair electrons. 1 pair of electrons. So pair means 2, right? And sometimes in the exam I ask you how many electron pairs oxygen has, that you count 1, 2, 3, 4 pairs. I say how many electrons it has, that you count 1, 2, 3, 4, 5, 6, 7, 8, or 4 multiplied by 2. Any questions? Clear? Okay. So now another definition that I'm going to tell you is the following. These bonds or these dashes that we write, so this We call that a covalent bond, or we call these bonding electrons. So these dashes, when atoms share those electrons, we call them bonding electrons, right? Because we form a chemical bond between those two elements or those two, right? So these are your bonding electrons. But the ones that they don't participate in bonding, we call non-bonding electrons. And I changed the color for the other one. These are your bonding electrons. Any questions? Is that clear? Let's do another example. So if I tell you to write trying to find an example that it hasn't. Okay, CCl4. What type of compound this is? Molecular compound, right? You don't see any metal, you don't see ammonium cation. So this is a molecular compound. I can spell it better. Molecular compound. So don't be afraid if you have like several atoms. Just write the question.
Yeah, I was just wondering what the difference is between a molecular compound and a covalent one.
That's a great question. So when we have the bonding between atoms, I'm going to write it. When the bonding between atoms are covalent, we name that compound molecular compound. So molecular compounds consist of atoms that are attached to each other by covalent bonds. Great question. So in ionic compounds, we don't have covalent bonds because atoms are not sharing electrons. Oops. Didn't mean to do that. Okay, cool. Still recording. Okay. Now okay. So when you see more atoms, don't be afraid. Just write the Lewis structure of individual atoms and everything comes together. So carbon, how many valence electrons it has? 4. It's in group 4A. It has 4 valence electrons. 1, 2, 3, 4. What about Cl? 7, right? So I put 1, 2, 3, 4, 5, 6, 7. Now, I should have 4 chlorine atoms, right? And I have 4, non-paired electrons here. So the logical way is that here, these chlorine atoms, I put around this carbon and connect those single electrons to each other, right? Can everyone see what I'm talking about? Or see what I'm saying? Okay. Let me go to this side. Okay, this is carbon, right? And then write 4 valence electrons. And then chlorine. 7. Chlorine. 7 valence electrons. So what we do, we have this carbon and then we put these chlorine atoms around it. And as I said, just have this non-paired electron in front of each of them because you're going to pair them, right? So in this way, it's like easier to do that. And now these 2 single electrons you connect with the dash, and that would be 1 covalent bond. This, 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 this. So this would be the structure of CCl4. Can anyone tell me the name of CCl4? Remember naming molecular compounds? Exactly. Carbon tetrachloride. This might explain everything software. It just updated itself now. It makes this feature really difficult. Okay, I'm gonna write this again. Tetrachloride. And just as a reminder, I mentioned that during the last class, and I'm going to keep mentioning and then send announcements. I eliminated your first 3 chapters from your final exam. So you have less chapters to study. Your final would be chapter 4 to 10. And however of chapter 10 we have time to finish. Okay, any question about this? Yes?
Is it the nature of compounds that each element fills their outermost shell?
Mm-hmm.
Okay, yeah, because I didn't know that, but I'm seeing that.
Yes, and we have exception from octet rule 2 that I'm going to talk about in the next class, that some of the elements, they don't necessarily want to reach an octet. But in general, your main group elements, they would like to whether lose or gain electrons or share electrons somehow that they have like octet or like duet for some of them. And the reason is that these structures, like your noble gases, are really stable and they don't like to participate in reactions and all that, and other elements want to be as stable as possible. Great question. Any other questions? Are we good with this? Okay. Now, what I'm going to talk about is double bond and triple bonds. So I told you when we have, and I'm going to write here, single bond. I told you when we have 2 electrons from 2 different atoms, and then we connect them with a dash, we call that a covalent bond. And here you just see one line, so we call that a single bond. So based on this definition, what do you think would be a double bond? When you have 2 dashes, meaning that you have 2 pairs of electrons being shared between atoms, or 4 single electrons. Does that make sense? What about triple bond? How many pairs, how many dashes should I put? 3, exactly. So you have 3 electron pairs or 6 electrons being shared between atoms. Any question about that? Okay, so now let's practice this. So if I tell you, write dot structure for O2. Okay. So remember, as long as you follow the instructions that I gave you, you can see where we have double bond, when we have single bond. So what is Lewis structure for oxygen? How many electrons around it? 6, right? 1, 2, 3, 4, 5, 6. And remember, have these single ones, towards the other elements. And the other one, what is, so if 2 oxygen atoms, right? The other one would be the same. So I write 1, 2, 3, 4, 5, 6. And now we have 2 electrons in each of our atoms that they're not paired. And we have only 2 oxygen atoms. So what happens is that we put 1 dash between these 2 electrons, 1 dash between these 2 electrons. And since this is really ugly way of writing that, what people do is that they write it as this. Or you can write it as this, doesn't matter. As long as you have 2 single bonds or a double bond between your oxygen atoms and 4 electrons around each of them. Does that make sense? So if I ask you how many pairs of bonding electrons we have between 2 oxygen atoms in O2? 2. 2 electron pairs. How many electrons in general, if I don't ask pair? How many electrons? 4, right? You count this, 1, 2, 3, 4. If I say in O2, in general, how many non-bonding electrons we have? 8, right? You count 1, 2, 3, 4, 5, 6, 7, 8. If I say how many non-bonding pairs we have? No, 4. Does that make sense? Okay, so this is that. And now let me do an example for triple bond. So if I ask you to write the dot structure or Lewis structure for N2. Okay, so for nitrogen, what is the valence of nitrogen? Number of valence electrons rather. 5, exactly. So you put 1, 2, 3, 4, 5. And then another, we have 2 nitrogen atoms, right? The other one the same. 1, 2, 3, 4, 5. And I put this 5th one here, and you see momentarily why I did that. And now you have 3 electrons here that are single, 3 electrons that are there that are single. What you do, you connect these, each of them, with a line. And again, since this is really ugly, what your book does, write it better like this. But I always do that myself to see, because you don't have to memorize what type of bonds atoms form. You can just write the dot structures for each of them and then pair them up. Any question about this? Okay, if no question, maybe I should, yes.
So the pairs of non-bonding electrons for N2, do we have to put those 2 electrons next to each other on each side, or can it be apart?
So you mean writing it like this?
Yes.
That would be fine. Doesn't. Yeah. As long as you have 2 non-bonding electrons, we're not worrying about that. Great question. So let me just go through the example 2, because you're going to see that in your homework, or like extra credit rather. If I ask you to write the electron configuration for cyanide, Cn-, okay. So again, don't be afraid. Just write it for carbon, nitrogen, and then consider that you have 1 more electron and write the structure. What is the valence of carbon? 4. So carbon has 4 valence electrons. Yes, 1, 2, 3, 4. How many valence electrons nitrogen has? 5, right? I put 1, 2, 3, 4, 5. Now we have 1 electron, right, that is added to our structure. So if I wanted to only have, so let me write this, that you should write total number of electrons for your Lewis structure. Okay, so how many, you write the number of valence electrons in carbon plus number of valence electrons in nitrogen plus, so what should I add here if I want to write the total number of electrons? So my carbon had 4, my nitrogen had 5, right? And what is this one? Plus 1, exactly. So now the total number of electrons would be 10. Any question here? And question, we want to pair these electrons, we want to form bonds, right? So what we do, you put a dash between these two, and these two, and now you should remember that nitrogen wants to reach an octet. carbon wants to reach an octet, and this is how we do these arrangements. So now, if I count the number of electrons in nitrogen, 1, 2, 3, 4, 5, 6, 7, 8, right? So nitrogen is all set. So where should I put the extra electron? Here, that is, I have a space, right? So that would be Cn minus. So when you write your structures, we have few exceptions from octet rule, but most of the time that can be your guidance to how to write these structures. Any question? Good. So now you can be able to see your extra credit quiz on Canvas. So just make sure to take it right after the class because the link expires, or like you cannot see the homework after 1:30 p.m. So, and you should be able to answer it in like 5 minutes. Yes. Oh, sorry. I thought you have a question. Yes.
So like you were saying, the extra credit, you're going to take it so it doesn't look like an assignment.
Yes, I'm going to delete it. And this is a good point that you mentioned. When you answer the questions, just take a note of what you answered, okay? Because I'm going to delete that and you're not going to see that again, okay? Does that make sense? Because I'm going to add that extra to your exam or like quiz or anything that you need points. So, for instance, if you one question you answer, I don't know, N2, just take a note on it, about that. So when I post, talk about it during our next class, you will be able, yeah. Oh, did I put it on Wednesday?
I don't know. I didn't look.
Could anyone access it? Yes? Oh, is it like the extra credit
No,
which
this
is
is the
due
one
today?
due.
Oh, you're talking about the previous one.
No, this one is due on the 27th, so Wednesday, but I accidentally opened that, so this.
Oh, that's fine, Just close it. Yeah, I'll open it again for you. Yeah, I was like, I'm pretty sure I checked several times.
Yeah, sorry, I picked the wrong one.
No worries. Just exit that. That's right. And the questions that I just asked you now was final for last semester. Do you guys need periodic table? I can also open it here. I can find it. Periodic table, okay. Yeah. Here is also your periodic table in case you need it. I'm going to have extra office hours. I'm going to send an announcement about it on Canvas.